Can simulation help in reducing the production cost, or will it help reduce the time taken for production? Or how can simulation help in creating prototype in new features and norms? All this and more will be discussed by our next set of panelists. First up, may I call on stage editor ETAuto, Nabeel Khan. Request you to kindly moderate this session. May I now call on stage CTO Sanden Vikas, Yuji Yamamoto, Head of Engineering Business Unit Vehicle Dynamics, Continental Automotive Components India, Jaidev Venkataraman. Can we please have a warm round of applause, please? Director Sales Operation ESI Software India, Anshul Gupta. Vice President South Asia and Managing Director India, Altair Engineering, Pavan Kumar. Senior Deputy Director and Head NVH and CAE Labs, ARAI, NV Karanth. And Managing Director, Comsol Multiphysics, Dr. Vineet, Dravid.
So now we are going to focus on the main aspect, how to save money, how to save time, and how to be relevant in the market, which is we have been trying to cut the design to rollout time from 4 to 5 years. It has come down to 2 years. And now in the morning we have heard that it is going to come down to 12, 14 months. So how much simulation is going to help? We are running short of time, so without making much of explanation, I'll just start with the presentation. May I invite Mr. Yuji Yamamoto to present his point of view. I request all the speakers to be precise and within the time limit, that is 3 minutes of presentation by each of you. Thank you.
Good afternoon. So this is an engineering project example. So I'm Yuji Yamamoto from Vikas group. Sanden Vikas and also Pranav Vikas, both company I'm managing. So this is an engineering project I said. This is a advanced project. As Mr. Raman said, this is important to have a shortcut to be compatible with the application engineering project. So this is so my specialty is thermal system. So this is addressing a future electrical vehicle thermal management system. So this is beyond BS6. This is a zero emission vehicle. So there is many challenges for the thermal systems. So some of the slide you show. Anyway, so we need to manage the cabin cooling and also heating. So heat source is the environment. India is a very severe market for that. Okay. So I'm learning every day, so how to operate so remote controller. So in fact, this complicated system also needs a very good controller, a so-called EVTMS, Electrical Vehicle Thermal Management System. So heat source is not only an environment, but also battery pack, and also traction motor, and the inverters. So those are heat we need to finally reject to the ambient air. Okay. So to make it happen, so we need to have several subsystems and many functional components. So you will see the list later on. So apparently, so I'm dealing with 3 major circuits: refrigerant circuit, coolant circuit, and also air circuit. So you need to have a good simulation tool and validated by testing. So this is one of the key messages. Next slide, you will see the actual design process for this example. Gray box means design process. And the light blue box is a simulation supported by pink box for the testing. So first, left side system concept. This is, in fact, the most difficult area. You don't have any simulation tool. So you need to create what do you want to do. So after that, of course, for the design, system design and component design, thermal simulation, system simulation, and also finally, FEA also need to do. After that, we need to validate or tuning or calibrate by testing. So this creates a lot of cost reduction and time reduction. So what is important to use a simulation is not only a reduction of the cost and money and time, but also to understand the system. So after making a complete system, making a prototype, using vehicle level testing finally. So if you don't know the system, how does it behave? If something wrong, so you don't understand how to fix the problem. This is also a very important point. Yeah, especially second row explaining software development, starting from algorithm development and the test case building up front. This is a front loading process. So then software development, controllability check, finally vehicle level validation, followed by kinematics simulation and testing. So again, what is the message for this slide is design by simulation. Getting several benefits I already explained. So then verified by tuned or calibrated by testing. So final slide, not final, sorry. This slide shows the exact relationship versus number of components listed up, left side. Then pink box is light blue is a simulation. So pink is a testing. So if we see the same A to A, so this is a link between the simulation and the testing. So as you can see, lot of simulation testing we are going to use to cut the cost and time. So I counted the number of simulation. It was 64. Testing was 52. So I came to the discussion point. So first one is thermal simulation, one of the important for this system. So yeah, simulation tool available, but if we improve the physics inside of the software, so this is a correlation, heat transfer or mass transfer. So we can improve a lot more. So this is my opinion. So second, mechanical simulation. This is more established. We are enjoying to reduce the time and schedule utilizing this simulation. So what is we need to improve furthermore is software simulation. So we have some standard hill test, etc. But so we have a lot of operation we need to validate. So this is a very challenging. What I propose is what I'm proposing based on the test case. Sometimes this kind of a big system, thousands of test case can be happen. So this can be upfront. We need to define. So how to simulate? This is we need to build up, cover all the testing point. That's all. Thank you.
Thank you, Yuji-san, for making it short, but still you took 2 minutes extra, 3 minutes. I would ask other presenter to be, precise and on time. So, Mr. Jaidev Venkataraman, Head of Engineering Business Unit, Continental.
Good afternoon, friends. Let me get on with the topic. Yeah? I think we should have simulated better to keep the time. But anyway, we'll get on to the topic. So I would like to talk about simulation, how simulation is enabling automotive development. Both simulation and automotive development are vast topics, so I won't cover the whole of product development and so on. So I would focus mostly on software and test. Software because automotive in the future, with the advent of autonomous, electrification, connected, is going to be all about software. Already today, advanced cars have more than 100 million lines of code, and I don't know how much more it's going to get. Test because cannot be avoided, though cars of the future is just PC on wheels, the quality criteria is not like PC. So test is going to be there, it's inevitable. But we need to find methods in test to fail early, to fail fast, and to fail cheap. So both software and test are going to be something that's going to drive us forward. So I will focus on that. One scenario that I wanted to explain is what is currently today happening in terms of simulation. The traditional V-cycle model out there, very easy. The left side, architecture, design, realization. The right side, integration, verification, validation. Though a lot of simulation activities is happening on the left side, I would still focus on the right side because that is reality today. A typical simulation that we do in kind of a brake system development. Typically a hill system. Hill is nothing but we convert a car into that box and we can do tests that we want to do on vehicle on the hill system. Make the box into software, we have a cell system. These two are predominantly used today in our development. And what is it yielding today in the biggest result is in software development, because the way we do software today is very different. In a typical brake system, about 800 software engineers working, almost making 8,000 to 9,000 changes per day, working on 300 projects. While all the creativity of software guys are preserved, software is actually built like a factory. Software 4.0 is like industry 4.0 today. We just make the creative process. After that, the build, the integration, the validation, the delivery, and the deployment is happening like a factory today. And that is where simulation is actually enabling this. And this is actually happening today. This is how we do software. And this is how we deploy. And keeping in mind how the deployment is going to change in the future, we think about deploying it in the embedded hardware and the plant. No, we also directly deploy it at OEMs. And in the future, we may have to deploy software directly to the customer at his vehicle, which is happening in other areas, but not in safety critical areas yet, but time is not far away in my opinion. So this is how we do software, and simulation is enabling us. What happens to a little bit of a future criteria or even a present criteria when we talk about autonomous driving and so on? The V cycle is completely changing for us. There is now becoming a W cycle, where simulation is becoming an inevitable part of development. Yeah, the first thing that we expect to happen is a OEM is building his virtual car, virtual actuators, virtual sensors, and supplying first this virtual car. And this is the only way forward in autonomous driving. Also given that virtual controller, virtual ECU, everything has to be built. Actually, a digital twin has to be built first before we go to the actual car. And on this digital twin, all the development is going to happen and the validation is going to happen first. This is how it is. The last speakers from MSc already told about 1 billion lines of code for autonomous function. I was just informing him, we started with 18 million miles, sorry, 1 billion miles, 18 million miles of testing to introduce an autonomous function. And slowly it has changed to 1 billion miles. And today the academia is talking about 11 billion miles, both simulation and vehicle testing together. So simulation is going to stay for autonomous vehicles, and it's going to be part of the development cycle like that in the middle. That's what we call as the W cycle now. So this is what the future is about. Maybe a small video, yeah, just to tell you why this is important. It's a vulnerable road user, and we have a collision mitigation system there, braking autonomously. But if you look at it, it's a simple test, but you can never do it really. You still do it really with dummies and so on. But how to simulate all kinds of situations, all kinds of varying speeds, varying vehicle dynamics, varying weather conditions, only simulation is going to be possible with this. Just to give you a small sample of introducing even a collision mitigation system, we need simulation. Otherwise, we can't do all the cases. And with that, I would just end that simulation is not finished yet because of autonomous driving that is coming into picture. Whatever we picked up from the aero industry, when we start applying into the automobiles, scale is completely different. Simulation today and in the future is a a separate science by itself. Yeah? The varying dimensionality, the varying road infrastructure, the varying dynamics, everything has to be simulated. And a lot of study is happening in this case. Maybe I speak about it during question hour, but this is the thought I would like to leave behind, that simulation is a science, and this is going to be highly pursued by academia and industry. Thank you.
Thank you, Jaidev. So now may I invite Mr. Anshul Gupta, Director ECIS Software.
Hello everyone. If I can have the presentation. So I think since morning you have been listening about simulation, how it can help in many different ways. We have seen some kind of recalls in the past. Cost of recall is quite high. If you see in US alone, there have been plenty of recalls over a period of year, and they are increasing. And in terms of number of vehicles, it's growing quite fast. Although, to be a little bit on the fairer side to them, 2 big recalls happens because of the OEM's starter kit and from one airbag manufacturing company. But nevertheless, the recalls have been quite a bit. These recalls have costed $22 billion in the past, and majority of that is happening because we are in the hurry to make new products, new cars, roll out as soon as possible. If you see, electronics and electrical components in 2013 have contributed to nearly 30% of the recalls, as opposed to only 5% before. That means it's growing. The chase towards rolling out the big, better cars every year is causing all the concerns. Nevertheless, if you go back to the traditional way, simulation can help in many different ways. Casting, welding, stamping, I mean, you name it, CFD, NVH, electromagnetism. There are a lot of things that one can do in terms of simulation in a traditional way for several years. I mean, some people have said that some equations haven't changed for several years. What you can do is that you can do it in a system level, you can do it in a cloud way, in whichever way, new fashion you could say. Of course, at the desktop level, you can also do it virtually. And that's what actually ESI already does it, like many other software providers. But I'm not here to talk about those things. What I'm talking about is this thing: can simulation only and only help when you are testing something, when you have a 3D model there? What if you do not have a 3D model, if you are at a conceptual stage? What if you are trying to see human ergonomics or serviceability of a part? What if you are talking about machine learning, you are talking about coupling, what you learn from testing, and that is what we call it sometimes, even when I don't have anything. I mean, when you are trying to design a rocket, you have never tested it before. When you are trying to design a battery, you have never tested it before. So these kind of things, let's try to figure it out. The V cycle, our colleagues have already talked about this thing, which is now turning them into W cycle. Most of the people are focusing towards the right side of the simulation, V as well. About 90% of our business is towards that thing. But then cost of fault is too high if you find the issues towards the last part of the V cycle or W cycle. If you do it towards the beginning, it is much better, much faster, much easier way. And that's where you are at the conceptual stage. You probably do not have a drawing. You just have some thinking in your mind. Why don't we do it this particular way? That is where system modeling really helps quite a bit into those kind of a thing. Some people even talk about reduced order modeling. So when you do reduced order modeling, you do simulations very fast. So think about a situation where you are talking about, let's say that I would like to analyze a situation of a battery charging, discharging, or whatever it is for 3,000, 4,000 cycles over a period of 10 years. If you try to simulate it, your simulation time will be matching 10 years. You cannot do simulation for 10 years. But model order reduction and system modeling can do it within 1 day or 2 days for the entire 10-year lifespan of such kind of a system. Other thing could be that how do you check for the serviceability of a component? So for example, you have manufactured something, you have put together something, and then somebody is driving that car, he finds out that the part has become faulty. He goes to the service station, he says, can you please replace this part? And the guy says, it will take 5 hours because I have to remove the complete engine and this part and that part and everything, and then only I can reach to that particular component. So that is where it is, can the person who is doing serviceability, the servicing, can he reach out to that component? What if he is a shorter guy or a taller guy or a fat guy or whatever it is or something? The other thing is this thing, that what would happen if he bends down too much and he has a problem? So it's a human ergonomics, quite a bit of thing. I mean, if he has to twist and bend down for like 5 hours, he cannot work tomorrow. So what about those kind of situation? Simulation actually can do these things also as of today. So this is possible, very much possible you can do these things. The other thing is this, a lot of people, and this is perhaps my nearly second last slide, simulation, a lot of people are talking about digital twin, hybrid twin. The point is this thing, simulation perhaps is not there to replace testing. What if we co-learn about something? So for example, one example that I have put together here is this thing for a battery monitoring system. What happens is this thing in the recent time or maybe in the near future, what is going to happen is this thing, there is a continuous charging, discharging, and all kinds of things happening with the battery. The data continuously goes to the service station. They figure it out, the battery health. They can change the software right there and then in your machine or in your car so that your battery goes into the better health system. That means not only they have to gather the test data, they have to simulate it in real time and feed it back to the system. That is what is called digital twin and hybrid twin. We are very much into that space of coupling testing with simulation. So what essentially is this thing that we all know that you can do components. We all know that at some point of time you can do assembly of the components to do simulation. You can replace your prototype. You can do complete car crash studies or something. Where we are today is this thing, you put together all prototypes in a virtual world, simulate it together, the effect of one prototype into another prototype. And that's what is driverless, ADAS, or whatever we are talking about. That is what is from my side. Thank you very much.
Thank you for showing a new dimension to use of simulation. Thank you so much. Now may I invite Mr. Pavan Kumar to give his presentation.
To start with, I have a vested interest in doing it fast. I have a plane to catch. So I'll try and do it as fast as possible. Having said that, can I have my PPT, please? You heard some very eminent speakers speak about the way they have utilized simulation and how they're gaining benefits from it. You see the vehicle today, the Vitara right there, and you heard from the chief engineer and the whole program in charge. I can only add small value to such a speech. And I thought I will add that value in terms of some numbers that I could do some research on. I think these numbers are not new to any one of us. By the time we reached year 2000, the vehicle replacement cycle had reached about 5 years. I'm told now it's even less than 2 years. Now all this is happening, and I blame it on our little phones. I think they've really spoiled all of us. We are looking at replacement cycles even shorter and shorter and shorter. And that's not going to go away. Competition is very much there. So how do we utilize this? The hidden sauce, I would say, the secret sauce, I think is simulation. And more simulation is the only answer. Simulation is here to stay. You've seen examples of companies like Toyota reduce time by almost 50%. I'm told it's even higher now. In particular cases like safety, 70% reduction in the case of GM. This is going to keep on increasing. And the earlier we apply this cycle, the better it is. I think my previous speakers spoke about this. How do we do this earlier in the cycle? If I remember Raman-san, he said the words front-loading of simulation. Front-loading of math modeling, I would say. You can actually go from a math model to a simulation cycle and derive a design from it, rather than use simulation as a validation example. So it's a huge difference. This is here to stay. It's going to continue. I would like to end my talk within time with a short video by a customer of ours who actually used this for CO2 reduction strategy, using simulation and lightweighting, as Dr. Sharma spoke about just before lunch, using this for a simulation technique.
The positive relationship with Altair, I mean, it really goes back to what I fundamentally said, and that's the foundation of our product CO2 strategy is lightweighting. And Altair is known, right, as the #1 knowledgeable organization and outfit from a technical standpoint as it relates to lightweighting and optimization. So lightweighting is going to continue. We've had a fantastic relationship with Altair up to this point in time, and we're going to be continuing to interface with Altair because we even need more lightweighting moving forward.
Thank you. Thank you very much.
Thank you so much, Mr. Kumar, for such a short yet impactful presentation. Now may I invite Mr. N.V. Kamath of ARAI, Karanth, Mr. M.B. Karanth from ARAI. Thank you.
So I'm from ARAI, Automotive Research Association of India, who is based in Pune, closely working with all automotive manufacturers, component manufacturers, regulatory bodies, software and hardware providers, test equipment providers, to bring safe green vehicles. That is with the focus. My talk is mainly on simulation-based activity, which will curtail the testing and also enhance the reduce the development activities in bringing compliant vehicles. Okay. This has been already echoed. Basically, what we are talking about is simulation is definitely required for any product design. So the virtual simulation is increasing because of the computing power has increased, parallel processing, robust optimization, optimized algorithms. But now what we are speaking is, which is the gap which we are filling it now, is continuously there is a material change, process change, which has been also talked about in, and also the loading cycle. There is a very complex loading cycle. These are also required to be put in. The effort in our ARAI has been put is, these are the areas are very much, having very good support from the testing side. Our CAE engineers are continuously working with the testing people in getting these algorithms or whatever the code robust, and they interact in turn with the software industry or the software providers in making their model very robust. That is the contribution from the CAE side, from ARAI, to make the virtual model or ultimately the product in the virtual stage itself very robust. So in the process we are, though AR is known for many of the experimental tests are now getting reduced. These are one of the main challenges what we are finding it. Basically, the new generation materials we have talked about, that is really required to be addressed at every stage. Even we are talking now from molecule to up to the final product. Particularly a classic example which was given in the morning was about the tire. Right from tire to at a different stage, it is taken care up to the pressure, up to the tire pressure simulation even. So even some of the critical area while designing is the joining, particularly when we are talking about the virtual certification area, this joining is very important. Wherever human into these things process, in problem here mainly in the small scale industry or some of the particularly bus commercial sector where the production volume is low, there is a inconsistency in some areas which will hamper the simulation or the testing gap. So this inconsistency we have to reduce, so bring a close correlation between the testing. So how the virtual can be made successfully is good correlation and a lot of statistical data to come out with. So these are already in the public commercial vehicle side. As per the EC regulation, there is a provision to go for the virtual. Using the virtual simulation, you can certify the vehicles, particularly the very costly tests. Once upon a time, even 6-7 years ago, actually the fully built bus has to be rolled over, 80-90 lakhs rupees worth is to be totally made scrap-like. Now the provision is made in a systematic manner after very close iteration of so much test data. Now the virtual, the certification is through virtual simulation. In between, it is not 100%. There are critical areas like joining, CG measurement. Still, we are following the experimental. So these are the rollover, then the roof strength, then all the protective devices like front, underrun, rear underrun, side. These are all now through virtual, it can be certified. Now, taking into the future scope, we are all closely working with the OEs in addressing this area in future course of time to come with seat belt anchorage, then side door strength evaluation, windscreen wiping area in commercial vehicles. Here, though the test time is very small for the experimental, the hardship that the manufacturers will have to is bringing all the way their mock-up to the test, then doing the test. Instead of that, the virtual, which can also be done in due course of time after sufficient deliberation. The other area which Raman sir has already talked about is the head form impact in the interior, where the material as well as the, from the human head point of view, some more data is required to be collected to make this also virtually possible. So these are all well supported by tests. That's why we could come out with a good correlation. Now this is one area why I want to emphasize is the lightweighting. This is a need of the hour we have talked about in improving the fuel efficiency. This is the work driven by ARAI CAE team only. Entire work has been done by the virtual team, wherein we have taken up a project in building a superstructure, aluminum superstructure bus. It is from concept coming up to the detailed design, then virtual simulation. At each stage we have ensured all the experimental validation has been done. Then compliance, this also complied, the regulatory requirement also. The bus prototype is also made, and now it is under testing and ready for the production also. So this is the work the CA engineers, virtual people have virtually who are working this thing on made it real. The close, that is the, I want to bring it to the notice of this thing. It is not driven by the experimental, it is driven by the virtual to the real. So this is the area, e-mobility. E-mobility, one area where we have talked about. EMI EMC is one area we are working on the simulation side, where the software provider is also closely working with us. If we can address this, the simulation, or at the diagnosis side, we can work towards to address this, because all the vehicles are now EMI EMC required, compliance is there. This is the area where we are going. NVH area we are working towards in bringing its virtual. There is a long way to go, where pass-by noise is a regulatory requirement, but it needs lot of model at the engine, interior, intake, exhaust, so many component level we have to address to bring it to that. It is a long way, but internationally also they are talking about indoor pass-by. That is, we are bringing track to the lab, now the lab to the desktop. That is the area we are moving towards. The rest of the area, particularly electric power motor, everything has been already talked about. I don't want to touch upon. In conclusion, whether the future, whether virtual will replace, the answer is whether the virtual simulation, for the future, it is early design optimization can happen. Yes, it is definitely, but can it replace? No. Because we have already talked about still there are gaps to be this thing. So we have to, what it will help is basically increase productivity, and we can arrive at a smarter product. Ultimate goal, virtual simulation is to be made available for design sign, enable for design sign off with the minimal or zero testing. That's what we want to tell. Thank you.
Thank you, Mr. Karanth. Now may I invite Dr. Vineet Dravid to give his presentation.
Thank you. Good afternoon, everyone. My name is Vineet, and I'm going to talk about how you can simulation 2.0. It should have been CAE 2.0 in hindsight, because I'm going to talk about a subset of simulation. So just very briefly, I represent a company called Comsol. For those of you who are not aware, Comsol creates a software called Comsol Multiphysics, where you can couple different physical phenomena and solve for them simultaneously. So it's a Swedish software. It's been around for about 20 years now. We've been in India for 10 years, and apart from interacting with the customers here, we also have built some products from scratch in India. So that's something we are quite proud about. And like I said, we build a multiphysics software, so you can couple different physical phenomena. Now, coming back to what I said, CAE 2.0, the reason I use that word is because we've heard of Industry 4.0, and we can debate that, and jargon aside, in the past 7 to 10 years, I'm sure all of you can appreciate the speed with which technology has been embraced throughout the whole product life cycle process, right from design to manufacturing. It's very seamless, very impressive. CAE tools have matured. The way CAE tools are used in the industry has matured as well. But I'm sure all of you will hesitate to say that there's a seamless integration of CAE tools in the product life cycle process. And we've heard that throughout the day today. Now, they are still used in a piecemeal approach. You go to the CAE team when you have a problem, and it takes time to get a result, and there's an iteration involved there, a few iterations, as Dr. Sharma said earlier today, and also Dr. Pradeep. Now, what's the reason for that? There are a lot of reasons. We can debate that no end. But I think the biggest reason is because most CAE softwares are wedded to older technologies. And these old technologies prevent them from migrating to new technologies which can enable scalability. Now, by scalability, what I mean is ease of use, ease of sharing information across departments in a cost-efficient manner, and also getting accurate and timely solutions when you're solving complex systems which have different physics involved in them. And this really creates a simulation bottleneck in a company, as we've seen throughout the day today. What I mean by that is when the designer faces a problem, they have to go to the simulation team, and then they have to wait. It's almost like the caste system that we all love to hate in India. We have a set of experts in the simulation team who are detached from everything else, and then you wait for information from them. It can take a long time sometimes. Then you work on the information, go back to them, and so on and so forth. And this has to end. I think Dr. Sharma said earlier that you have to democratize simulation. Dr. Raman hinted at the same things in the previous talk. And this can be done by making sure that CAE softwares are available to everybody, and they're easy to use. So it should not be the experts alone who have access to the software. It should be the designers who can, on the go, change their design parameters and see how it affects the performance of the design that they are making. Or the manufacturing process, if they change the manufacturing process, they should be able to quickly see how it's going to impact the whole process. And that, I think, is something that you all need to demand of the CAE softwares, because once you demand it, we'll give you that, and that is simulation or CAE 2.0. You set a framework of expectations from CAE tools, which will enable us to integrate CAE softwares seamlessly in the entire product lifecycle system. That's it. Thank you.
Thank you, Dr. Dravid. It was really nice presentation, and you maintained the timeline also. Since we have our two speakers who has to catch flights, so in the interest of time, rather than me asking question, I would open the floor for questions. Please identify yourself and ask your question, and do name the speaker from where you want the answer. So I think there are no questions, but I have some questions for you guys. I'll ask one or two questions. Mr. Pavan Kumarji, I want to understand, because while I was setting up this program, I spoke to a lot of people in the R&D team, OEM, component, all the side, but we see still use of simulation is still at a limited stage. There are certain area where it is being used, mostly in the testing field. Do you think there's still lack of awareness, or what is the reason that is, pushing people from use of simulation, the kind of use we have overseas? Is cost also a factor?
Yeah, Nabeel, good question. Good question, I would say. I don't completely agree with your assessment. Simulation is now something which is almost all over, all pervasive. But is enough simulation being done? Probably yes. There is always room for doing more. I think there can more cases that we can validate with simulation rather than testing. I especially like Mr. Karanth's point on some of the areas where simulation is not yet being applied in a wide scale is EMI, EMC, and electrical systems, motors especially. I think these are areas which are the next frontier that OEM should embrace Today, the OEMs have made major progress, amazing stuff. In fact, they are pushing people like us to do more physics. So that's a good place to be.
Mr. Karanth, you just mentioned an interesting point that simulation-based certification. How reliable it is and how far are we, how much we can do that?
These are all driven by international regulations also. We cannot just go here in India. We follow closely European regulation. There are certain, you have to ensure whatever you are virtually certifying through virtual simulation is whether you have to go right from the model. It is model verification, particularly the geometry right from there, and what process has been. You have to ensure there is a consistency in the whatever the test that has been carried out earlier. This is the first and foremost requirement. You have to establish a test correlation. Any virtual certification cannot be done straight away. Through virtual this thing. It needs to be ripe enough. Even Europe adopted for bus rollover almost a decade ago. We had to wait sufficiently this thing, looking at our way of production. Basically each bus, it is in a small scale, this thing, it has been manufactured. Consistency in its manufacturing itself, if it is not robust, then a whole assumption of the joining, everything will go wrong. So it is very important to ensure those, still those areas are, physical testing is done, ensure and then correlated. So it is not 100% at.
Dr. Vineet, Dravid, I would like to bring you here. You talked about next level of simulation. Could you please put some light, what are the learning from the global market? Which are the area we are missing? Which are the area we can probably capture in the next level of simulation? Briefly.
I think as has been discussed throughout the day today, integration of simulation early on in the design process. And there were some examples which I didn't share because of lack of time. But basically, create easy to use tools. And when I say easy to use, it should be accessible across teams. It should be cost efficient. It can't be too expensive. And you should give these tools to designers. That's what we need to focus on. And that's what we are doing, of course. But that is going to take simulation to the next level and going to ensure that you see good productivity out of the simulations that you perform.
Thank you. Mr. Yuji Yamamoto, I want to understand from your global experience, what are the key area where we can use simulation? What are the new area pointed, where you think we should start using simulation that will help us in cutting cost and time?
When I explain the engineering project, if it is a new system, there is no model to use. So if it is an existing system, you can have a lot of model and the software. But nevertheless, we need to build up the model for the new development for the future. So you can understand how system behave also. If we have a problem in the, I have a 39 experience for the summary system development. I've never had a project zero defect, always a problem. I'm 39 experience. So this is a point.
Big achievement. I would like to bring you here, Jaidev. You are also a global player. You have exposure. What are the key takeaways for you when you go to the overseas market when it comes to simulation? Briefly.
I think I also covered this in my part where I said the focus in the overseas market and European market is all towards automated, connected, electrification and so on, and more towards software. And in the later part of my presentation, I talked mostly about autonomous and how you cannot release a automated function, just a ACC or a chauffeur or cruising chauffeur or automated parking. So all these functions are getting discussed. And they're all struggling how to prove this function on the road. What is the amount of test cases needed? How to do test coverage? What is completion of test? What all conditions have to be done? How to handle all these dimensions? How to handle unpredictable situation? You tune a software for pedestrian, and what happens if an animal comes? What happens if the animal has 4 legs, 1 leg is broken, 3 legs? So there are so many situations that has to be covered. And this is what in the overseas is going. And that's why simulation is more and more getting a science. A lot of academia are getting involved. Gaming industries are involved in creating these simulation packages. And it's going to stay. As I said, it's going to be a science. And we are all going to see how this is going to develop.
Mr. Anshul Gupta, you talked about the after sales part where you can use simulation. Where the other area you think that, do you think in the pre-conceptualization area also we can use simulation?
There are two different things. One is after sales service and one is the before we cycle. You can try to couple those things, but we should keep it separate for the time being. That you can learn from the post-sale service, for example, accident rates. I learned from last time from Tesla side that what they have done is this thing that the seating arrangement is not quite comfortable for people, and people have been complaining. All they have done is this thing, they have upgraded their software to next level, and they say, well, you just upgrade your software in your car and automatically it will push back seats for every single person. That's where simulation can really help and tweak it out.
Thank you so much, gentlemen, for being so precise and helping me maintain the time. Thank you so much. This comes to end of this panel discussion. Thank you so much.